This is our second topic. I just kept this slide to remind you that you have to study what is the need for a separate data warehouse. We are moving on to the third topic, multi-dimensional data model. We have seen an introduction as part of day 2 material. Now let's see some more details on multi-dimensional data model. It is the most popular data model for data warehouses. So we are calling it as also data cube because we view data in the form of a data cube. A data cube allows data to be modeled and viewed in multiple dimensions. Dimensions are the perspectives or entities of an organization. We have seen all this, but you have to see the points once again, and we will see what is a multi-dimensional data model. I hope you remember this figure. This is a data cube for all electronics data. This is a data warehouse for all electronics. We have three dimensions. One is item, and second one is time, and the other one is location. Okay, we have item types. Different items are home entertainment, computer, phone, security, and we have divided the time into quarters, that is quarter 1, quarter 2, quarter 3, quarter 4, which represents the quarter of months, that is quarter 1 represents January, February, March, like that. And we have location. It is in the form of cities. We have different cities: Chicago, New York, Toronto, and Vancouver. And this data cube is a 3D data cube which represents time, item, and location. And the measure displayed is the dollar sold or the sales amount. Here the value is represented in dollars. That is represented in the cells. The same data cube can be represented as a table. This is a table view or the 3D view of sales data for all electronics. You see any one of the dimensions should be repeated so that we can represent all the values as a table. Here we are repeating the item, home entertainment, computer, phone, security, in each and every location, for each and every location. So we have for location Chicago and for the item, and we are representing the values as per quarter 1, quarter 2, quarter 3 and quarter 4. So this is the 3D view of sales data for all electronics. So we can represent the data like this for understanding the data cube in a more effective manner. To represent a multidimensional model, we have to use two types of tables, that is dimension table and fact table. Dimension table is used to describe each and every dimension in the particular data cube. Each dimension may have a table associated with it which describes that particular dimension. For example, here we have item dimension table, which is used to describe item like item name, brand and type, and we will have another dimensions that are location and quarter. To represent those dimensions, we will have another tables. So these are the dimension tables. And another one is fact table. A multi-dimensional data model is typically organized around a central theme. We will have a particular concept or theme. Based on that, we are developing some data cube or multi-dimensional model. So that should be represented as a fact table. Here we are storing the data cube for seeing the sales amount happened. So sales is the theme here. So sales is the fact table which we can represent using a fact table sales. Facts are numerical measures or quantities by which we want to analyze relationships between dimensions. Here we are using sales amount in dollars. We can represent it as dollars sold, or we can have a data cube for representing number of units sold. That can be represented as units sold or amount budgeted, like that. The fact table will contain two concepts or two things, that is, one, the name of facts or measures, here dollars sold, and there will be keys to each of the related dimension tables. Always the fact table will be related with one or more dimensions, so that should be represented in a fact table using keys. Here we will see a data cube with more than 3 dimensions. Actually, a multidimensional data model or a data cube is n-dimensional, but for the simplicity we are studying it as a 3-dimensional model. But any ND data can be displayed as a series of n-1 D cubes. For example, we are considering a 4-dimensional data cube, and this 4D data cube can be represented as a series of 3-dimensional data cubes. Here the same example we are extending with a additional dimension that is called as supplier. Okay, here we have supplier 1, supplier 2, supplier 3, and it may be up to supplier n. So we will have n number of 3D data cubes to represent a 4-dimensional data cube. For example, here for supplier 1 we have item, location that can be represented using a 3D cube, and we will have a series of 3D cubes to represent the 4th dimension. Okay, a 4D data cube representation of sales data according to the dimensions time, item, location and supplier are displayed here. The measure displayed in each and every cell is dollars sold. Okay, this is an example for a 4D data cube. Now let's see one more concept that is known as cuboid. Okay, we will see what is a cuboid. A data cube at different degrees of summarization is referred as a cuboid. So what is a cuboid? A data cube at different degrees of summarization can be referred as a cuboid. Okay, we will see with an example. Before that, we will see some points. Given a set of dimensions, we have a set of dimensions, we can generate a cuboid for each of the possible subsets of the given dimensions. For example, we have 4 dimensions. We can make all possible subsets of that. For example, subset of 3 dimensions, or subsets of 2 dimensions, or subsets of 1 dimension. Like that we can generate. The result would form a lattice of cuboids. So a lattice of cuboids will show the data at different levels of summarization. Okay, each and every lattice of cuboid will be used to show the data at different levels of summarization. The lattice of cuboid together we are calling it as a data cube. So we will see what is a cuboid and what is a data cube, or what is a lattice of cuboids with the same example. This figure shows a lattice of cuboids making up a 4-dimensional data cube. See, from bottom to up we have 4D cuboid, that is the 4-dimensional data cube with 4 dimensions that are time, item, location and supplier we have seen already. But we can view the data in different levels of summarization or different levels of abstraction. For example, we can view the same 4-dimensional data based on the subsets that are 3 dimensions. For example, the 3-dimension subsets include time, item, location and time, item, supplier, time location supplier, item location supplier. These are the possible subsets of the 4 dimensions when we view it as a 3-dimensional data cube. So that is the 3D cuboids, and we can see it again as 2-dimensional summarization. For example, time, item, location can be again considered as time, item, time, location and item location as the subsets. So this is the level of 2 dimension. So this is the 2D cuboids, and we can see the summarization data based on time only, or item only, or based on location only, or supplier only. So that is the 1-dimensional cuboid. And if we consider it all together, that is we are considering all sales amount, or what is the total sales amount, not based on any condition. It can be given by this level. So that is the 0D or 0-dimensional cuboid. So these are the different levels of summarization we can see a data cube. That is the advantage of data warehouse. We can see different levels of summarization or different levels of abstraction we can maintain. That is shown here. So this is known as lattice of cuboids, and all these cuboids, lattice of cuboids will make a data cube. So together we can call it as a data cube. So each cuboid will represent a different level of summarization. So we can see each and every levels here, and the bottom layer is called as the base cuboid, and the top cuboid, or the 0-dimensional cuboid, is also known as apex cuboid, that we will see in the next slide. So the cuboid that holds the lowest level of summarization is called the base cuboid. So that is the actual data we are storing based on all levels, all dimensions. Okay, that is known as the lowest level of summarization, and we can move up to the higher levels of summarization, that is third, second, first, and up to the 0th level. The 0D cuboid, which holds the highest level of summarization, is called the apex cuboid. It is denoted by odd. Here, this is the total sales or dollars sold summarized over all 4 dimensions. So the total sales can be seen by this cuboid. Okay, so this is the concept of multidimensional data model, and you have studied what is a multidimensional data model. We have seen 2 examples. One is based on 3 dimension and the other is based on 4 dimension. Then we have seen multidimensional data model is represented using 2 types of tables. One is dimension table and the other is fact table. Okay, then we have seen another concept called cuboid, and we have seen what is the lattice of cuboid, and together we can call it as a data cube.